Hello viewers, welcome to part 1 of the video series on numericals on shear strength of the soil. In this video, we'll see how to find the shear stress parameters of the soil, that is cohesion and angle of internal friction for the data provided from the laboratory test. For demonstration, we have taken the data related to the triaxial compression test, and with the given data we have to find the shear stress parameters of the soil in terms of total stress and effective stress. The data that is provided to us is the cell pressure, that is sigma c, and it is also called as minor principal stress sigma 3, deviator pressure and pore pressure. In order to find out the shear stress parameters, we need to draw a mohr circle, and in order to draw the mohr circle, we need to find the values of sigma 3 and sigma 1. Sigma 1 is nothing but the major principal stress. Now, as we can see, the value of sigma 3 is provided to us. We'll have to find out the value of sigma 1. So sigma 1 can be calculated by adding the values of the cell pressure and the deviator pressure. As we can see, the cell pressure for first trial is given as 80 and the deviator pressure for the first trial is 175. If we add both these values, we'll get the value of sigma 1 for the first trial as 255. Similarly, we'll add the values for the cell pressure and deviator pressure for other two trials, which comes out as 390 and 510 kilonewton per meter square respectively. Then we'll find out the effective major principal stress value, that is sigma 1 dash. That can be obtained by deducting the value of sigma 1 from the pore pressure. The sigma 1 value for the first trial, as seen, was calculated as 255. If we deduct that value from the pore pressure, that is 45, we'll get the value of sigma 1 dash as 210 respectively. We'll then find out the values for the remaining trial, that comes out as 340 and 450 kilonewton per meter square respectively. And we'll also find the effective minor principal stress value, that is sigma 3 dash, which can be obtained by deducting the value of cell pressure from the pore pressure. So for the first trial, we get that value as 35, and for the remaining two trial, we'll get the value as 100 and 150 kilonewton per meter square respectively. Once this calculation is done, we'll take a graph paper and we'll first draw the x-axis and the y-axis. The x-axis will be representing the normal stress and the y-axis will be representing the shear stress. Then we'll choose a scale accordingly. As in this case, the scale is taken as 1 centimeter is equals to 50 kilonewton per meter square for y-axis and 1 centimeter is equals to 25 kilonewton per meter square for x-axis. Then we'll plot the points and label it accordingly. Now, first we find the shear stress parameters in terms of total stress. For the first trial, the sigma 3 value is 80, so we'll plot that point in the graph paper and we'll represent it by point A. The sigma 1 value for the first trial was 255, so we'll plot that as well on the graph paper and we'll label it with point B. We'll then find the center of these two points, that comes out as 167.5. We'll label it with point C. Now we'll take C as the center and AC as the radius. We'll draw a circle touching point A and B as it is seen in the graph. So this is how we have to draw the mohr circle. So following the same steps, we'll draw the mohr circle for the remaining trial as shown in the graph. Once all the three mohr circle is drawn, we'll draw a tangent which will be touching all the three mohr circles. We'll note down the intercept and the slope angle. The intercept will be giving us the value of the cohesion and the slope angle will give us the value of the angle of internal friction. So for the case of the total stress, the intercept, that is the cohesion, comes out as 50 kN per meter square, and slope angle, that is angle of internal friction, comes out as 18 degree. We'll follow the similar steps to find the shear stress parameters of the soil in terms of effective stress. We'll first plot the sigma 3 dash value, that is 35, and we'll label it with A dash, and then we'll point the sigma 1 dash value, that is 210, and we'll label it with B dash. We'll take a center of these 2 points, that comes out as 122.5, and we'll label it with point C dash. Now we'll take C dash as the center and A dash C dash as the radius. We'll draw a circle which will be touching A dash and B dash respectively. Similar steps is to be followed to draw the mohr circle for the remaining trial as shown in the graph. Once all the three mohr circles are drawn, we'll again draw a tangent touching all the three mohr circle. We'll note down the intercept and the slope angles. So in terms of effective stress, the intercept, that is effective cohesion, comes out as 60 kN per meter square, and the slope angle, that is effective angle of friction, comes out as 20 degree. So that's all from this video. If you have liked the video, hit the like button, share it with your friends, and subscribe to my YouTube channel Bright Mind EduPoint for more videos related to various topics of civil engineering. Thank you.